welcome to Cytocentric Academy Training. This is Dr. Yan He, a senior scientist from Biospherics. In this unit, we will talk about the risk-based approach to chemical disinfection and sterilization. So, what is sterilization? According to definition from CDC, sterilization describes a process that destroys or eliminates all form of the microbial lives, and is carried out in the healthcare facilities by physical or chemical method. It can be done in using steam under pressure, dry heat, ethanol gas, hydrogen peroxide gas plasma, or liquid chemicals. When liquid chemicals is used to destroy all form of microbiological life, they can be called chemical sterilants. For ex vivo systems, there's two chemicals we would like to recommend to our customers. One is called vaporized hydrogen peroxide, VHP. Another one is chlorine dioxide. So the most common questions we got is when we should perform sterilizations. Just before you start process patient sample is a good time for a complete sterilization of systems. Or anytime you have a confirmed contamination that will not be eliminated through disinfections, which is based on your environmental monitoring data, we call evidence-based manner. Sterilization is intended to convert absolute meaning. Some health professionals and the technical and commercial literatures refers to disinfection as sterilization, and items as partial sterile. However, there are two different terms. So what does disinfection really refers to? It refers to a process that eliminates many or all pathogenic microorganisms except bacterial spores on an inanimated object. In healthcare setting, objects usually are disinfected by liquid chemicals or wet pasteurization. Each of various factors that affect the efficacy of disinfection can nullify or limit the efficacy of the process. Disinfection in ex vivo system is completely different from open room air-BSC. In an open room air-BSC, we were taught to spray the disinfectants everywhere and whenever, and keep spraying, because wet time is critical for efficacy. However, the ex vivo system is fundamentally different because it is closed, so particles cannot randomly fall into the cell process space. It is closed, so the crack continuously swipes any generated particles away. And it is closed, so disinfectant fume can build up, and it is closed. Therefore, those risks are inverted as compared to room air BSC. What does it mean? In the open room air BSC system, the overall particles, including both variable and non-variable particles, are relatively high because it's open. There's no chemical fume risks. If we are using the same SOP in the closed systems, such as Biospherics Xvivo systems, the overall particles, particularly variable particles, are dramatically decreased. However, because it's closed, the chemical fume risks are significantly increased. The overall risks are inverted. Furthermore, if you can mitigate the process using the new SOPs and choose proper disinfectants, those increased fume risks can be controlled in the ex vivo systems. So the choice of disinfectants are critical. There are hundreds of disinfectant formulations registered with the EPA. The user should consider the ingredient carefully. We highly recommend customers refer to the manufacturer data and your own data for efficacy of selected disinfectant. Scientific team from Biospherics tested several EPA-registered disinfectants. Based on their cytotoxicities and build-up fume risk, they are classified into three categories: low risk, manageable risk, and high risk. We will share our data with you soon. In order to test the cytotoxicities, we incubated cells with selected disinfectants in a closed chamber mimicking a built-up film in a closed environment. Those transfer chambers are kept in a processing chamber in Xvivo system and are able to maintain oxygen and CO2 for a period of time. At the end of the experiment, cell viability will be measured using crystal violet assay. To test the build-up film, we use a built-in function in the Xvivo system to continuously monitor VOC, volatile organic compounds, inside the chambers. The first cohort of the disinfectant I'm going to share with you is TestQ, CleanSight, and Vercon S. They belong to low-risk group. TestQ is a quaternary ammonium-based disinfectant. Crystal violet data indicate that TestQ did not induce any fume-based cytotoxicities. Similar results were observed in a CleanSight. It is a citric acid-based wipe. However, it does leave a soapy residues on the floor, which needs an extra cleaning. Vercon S is peroxygen compound-based tablet. The heat map of the crystal violet assay showed those cells exposed to the Vercon S had the same cell viabilities as those in the control group. Next, I'm going to introduce Spore Cleanse, which belongs to manageable risk group. Spore Cleanse is a peroxyacetic acid plus 1% hydrogen peroxide-based spore cyto. As you can see, it indeed showed a fume-induced cytotoxicities, and also intensive use can pose a corrosion on a certain instrument, like the microscope lens shown here. The reason Spore Cleanse is classified as a manageable risk is that its built-up film can be removed by using one of the Xvivo function, log dilution ventilation. Log dilution ventilation is a process to exchange gases inside the Xvivo systems with triple filtered medical grade tanked gases. It can be done in a buffer chambers and process chamber in the Xvivo system, and it can be done separately. Therefore, if intensive use spore cleanse is needed, we recommend a log dilution ventilation after each use. However, log dilution ventilation cannot get rid of all type of the fume risk. Disinfectants I'm gonna talk about next belong to high risk group. The built-up film cannot be easily removed by the ventilation and can pose harm to your cells and tissues inside the Xvivo systems. They are alcohol-based disinfectants, such as isopropanol, ethanol, and candy wipes. Here we showed a representative image from the test of the candy wipes. It clearly showed a fume-induced cytotoxicities. Most important is our VOC monitor data indicate isopropanol and the candy wipes generate huge VOC during experiment, and they cannot be cleared by log dilution ventilation, even for months. So when you choose your disinfectant using in the Xvivo system, please read their ingredients carefully, like candy wipes contain quartz, but also have alcohol in it. Please try to avoid the ones with alcohol and use inside of the Xvivo systems. Besides disinfectants we listed here, we recently tested some oxidation-based disinfectants belongs to the such as bleach and hydrogen peroxide, whose concentration is greater than 1%. So similar approach we use for test cytotoxicities. We test two concentrations of each chemicals. Crystal violet data showed both bleach and H2O2 has fume-induced cytotoxicities to the cells. A6, A7, B6, B7 in the top panel, and the four corner wells in the bottom panel are cell-free control wells. Bleach also showed corrosion damage in some instrument. We didn't show the data here. Another product you could try is BioShield 75. According to your manufacturer instruction, spray these chemicals on the surface will provide to up to 90 days protection against microbial attack, but we haven't tested this product in Xvivo system yet. Once you choose your appropriate disinfectants, you will decide how often you need to disinfect your systems. But before you we go through that topic, I would like to remind you again that the Xvivo system is fundamentally different from room air BSC, which means no random particles will fall on your surface. HEPA-filtered medical-grade tank gases will significantly reduce the bioburden. Controlled temperature and relative humidities will inhibit microbial growth. Plus, it is closed. So the Xvivo system has a unique feature called continuous recirculating atmosphere conditioner, aka CRAC, which you already heard from me several times from previous slides. It helps clear particles from the cell processing area and return filtered gas to the chamber. Your chamber will getting cleaner and cleaner over the time. However, CRAC cannot reduce chemical film because there's no gas exchange. So unlike open room air BSC, extensive use of disinfectants is not necessary and not recommended for Xvivo systems. In addition, spray disinfectants inside the Xvivo system will put more film risk and add more non-variable particles into your systems, so no spray and pray. And mechanically wipe is a better way to disinfect the surface. In the next few slides, I will cover principles and techniques of disinfecting methods. There is also an online video from Biospherics can show you how to do your disinfection. The first time the Xvivo system is installed, all the surface inside the Xvivo system should be disinfected. If the chosen disinfectants create a fume risk, the log dilution ventilation should be used to reduce the chance of build-up of the risk fumes. For the routine disinfection, we will still follow the rules of evidence-based manner. We strongly recommend that customers establish a robust environmental monitoring program that can guide their own disinfectant use. As I mentioned previously, frequency of disinfection can help manageable risk to cells and tissues in a closed system or add to it. The only thing that happened inside the Xvivo between the after use disinfection one day and the before use disinfection the next day is that the atmosphere is continuously HEPA filtered by CRAC cleaner and cleaner. So re-disinfecting the system the next day before use may not reduce the risk to the cells any further, but just induce more humidities and risk to the systems. Also, it is not necessary to disinfect all surfaces in a daily basis. The only thing you need to wipe is proper risk surfaces. For Xvivo system, the entire nominal flow hood is considered a proper risk surface because it's open to the room and the personnel. In the buffer chamber, the floor, walls, and the doorknobs should be disinfected daily as the entry point to the rest of the systems. Only the gloves, cuffs, sleeves, floor, and the doorknobs of the processing chamber should be disinfected daily. If there's a visible contamination in other places, of course, clean and disinfect it more than the proper risk surfaces. The walls, ceilings, and the glove front are not considered proper risk surfaces and should only be disinfected when necessary, not on a daily basis. For incubation chambers, only the edge of the shelf and the doorknobs where the gloves touch should be disinfected on a daily basis. Again, if there is a visible contamination, please clean and disinfect whenever and wherever is needed. Then how to do it? For wiping the proper risk surfaces, you need to bring a damping clean room wipe or mops, not in a dripping wet way, into the Xvivo system in a sealed container or bag that has been surface disinfected in a nominal flow hood. Wipe proper risk surfaces with the wipes or mops. Place those used ones in the waste bags or container to minimize fume buildup in the chamber. Use non-blunt forceps if needed for the range. For imported materials, you need to wipe items with disinfectants in the nominal flow hood before imported. First, you want to use disinfectant dampener wipes to physically wipe all the surfaces of your gloves. And then use a fresh wipe systematically and thoroughly wipe all surfaces of each item as you place it in the back of the laminar flow hood to dry. So clean every single imported item is more tedious and error-prone if many small items need to be disinfected every time you do a routine process. There are some tips can make this step more efficient. Import bags or flags or other small items rather than individual flags and store them in the Xvivo system. Then use surface disinfectant bags rather than each item. Or assemble kits for routine process like cell pathogen and get them gamma radiated for sterility. Then you only have to surface disinfect the whole kit to import it. We will show you how to use our Xvivo SOP template for easy planning for material and kits in a future unit. So planning ahead saves time. At the end of the section, I would like to give some examples of choosing between disinfection and sterilization for your system and which chemical should be used. First, when the Xvivo system just installed, you could use spore clamps to do a thorough disinfection by wiping all surfaces, followed by a log dilution ventilation or multiple log dilution ventilation. Then confirm the disinfection, use touch plate or swabs followed by analysis for the presence of the microbes. Also test the cell culture, look for a sign of fume-based toxicities. Then after a sterile environment is confirmed, you start to optimize your operation. You could use TextQ, Vercon S, and or CleanSight for once daily disinfections of the proper risk surfaces in the Xvivo system, and use spore clamps for once weekly disinfection. Or imported materials need to be disinfected in the laminar flow hood. Use a proper disinfectants. Alcohol-based disinfectants can be used for disinfecting imported materials in the laminar flow hood or clean outside of Xvivo systems. We would recommend more frequent routine environment monitoring at first, and then less frequent as evidence is accumulated of the consistent expected conditions. Again, evidence-based manner. After the PQ and before the first production batch of the patient cells, many customers will do a system-wide sterilization, use VHP or chlorine dioxide. Once you start your routine GMP operations, just continue the routine disinfection environment monitoring programs. If a rare contamination is confirmed by the EM, first of all, remove all cells and tissues from the contaminated chambers. Then disinfect the chamber thoroughly with the spore clamps followed by log dilution ventilations. And repeat the EM. Consider the gas sterilization only if the contamination cannot be removed by the routine disinfections, and also repeat the EM to confirm the sterility after that. So today, we're talking about the difference between the sterilization and the disinfections, also the chemicals for the both procedures in the Xvivo systems. We also go through how to do the disinfections in the Xvivo system, including the frequency, proper risk surfaces, and the basic disinfection principle and the techniques. And at the end, we give some examples about the disinfection or sterilization scenarios. I hope you enjoyed this section, and thank you for your attention. If you have any questions, please do not hesitate to contact us via email or phone call. All contact information can be found at www.biospherix.com. We are always here for you. Thank you, and see you at live section.